All right. Good morning, everybody. Welcome to the second day of our ENIGMA Symposium. I'm very pleased with the first day. I think we heard some really fine talks, and it was very well integrated, I think, across the themes so far. We're going to have a lot more now of the rocky world and planetary science world. And I just want to point out why we're interested in planetary sciences, why we're funded by NASA and not by NSF. The chief scientist of NASA, not the chief scientist anymore, but the head of science, NASA, is Thomas O'Brien, who is the boss of Mary Wojtek. And Tomas's job is to make sure that when the decadal surveys come out every 10 years, and missions and telescopes and other space-based projects are proposed or given some endorsement by the scientific community, that those projects go forward as best as they can within a budget. And this is the big problem for NASA, is that budgets are often very highly constrained by strong delays or long delays in missions. And this was very easily demonstrated by the James Webb Telescope, which is a success in terms of its launch, but it was many years behind schedule and many billions of dollars over cost. But thankfully it's at the L2 position. Its lenses are functional. And for those of you at Rutgers, we have telescope time in our astronomy department because two of our astronomers are scientists that have been selected to be amongst the first to use the James Webb Telescope. Now, the James Webb Telescope has many possible functions, and this is obviously an area where our cosmologists, our astrophysicists are worrying about things like dark matter and dark energy, what they are. These are major questions in physics. It was not designed, I just want to make sure that everybody understands this, it was not specifically designed for exoplanets. So there are other telescopes that are being designed for that, but this was not the primary mission of the James Webb Telescope when it was designed in the late 1980s, by the by. All right, having said that, we are building other telescopes, and the 30-meter telescope, the TMT so-called, is being designed to go on Mauna Kea in Hawaii. It will be funded by a consortium between the Moore Foundation, NASA, and the European Space Agency. This is going to be one of the largest telescopes, if not the largest telescope ever built on land. You cannot launch such a telescope into space. The payload is way too big to get it into space. And why do we care? The larger the telescope is, the more photons it can collect per unit time. And that allows you then to see things like a planetary atmosphere, which is a very time-consuming process for telescopes, both in space and on land. It's much easier in space, but on land, we have to go through atmospheric processes on land in our system, and there are ways of nulling them out, but it is complicated. So I just want to bring that up because as we move along, one of the missions that our group and all other NASA-based large programs, large-ish programs, to NASA we're not a large program, but large-ish programs are for missions. And so we're going to hear today from two people that work within our solar system. One is Shauna, and the other later on in the day is Kevin Hand, who's at the NASA Jet Propulsion Laboratory, who's working on a mission to Europa, a lander. So without further ado, let me close with my comments, and I'll reintroduce Nathan, who's going to introduce Michael Wong.